Okay, so today we're going to talk about the Pythagorean Theorem. Hopefully you guys all remember that from, I don't know, 6th or 7th grade is probably when you first learned it. A squared plus B squared equals C squared. And you always have to remember C is always the hypotenuse. Which is the longest side. And it's opposite the right angle. So in my picture, there's the right angle. C has to be opposite. So what I'm going to do now is I'm going to show you guys one of the proofs for the Pythagorean Theorem. You can actually just watch this if you want to. You don't have to write this down, okay? But I just want you, there's multiple proofs for the Pythagorean Theorem, and this is just one of them. So I want to show that to you guys. Alright, so this is just one of the proofs for the Pythagorean Theorem. There's lots of them. But this particular one, we've got, imagine those are squares. I know they kind of look like rectangles, but pretend they're squares. Because when I originally made this slide, I had a projector that distorted everything. So anyway, okay, so the area of the large square is going to equal the area of the four triangles plus the square here, right? Does that make sense? So if I want to know the area of the large square, how do we find the area of a square? Don't you just multiply the sides together? Yeah, you just multiply the sides together. So this square, the side is equal to a plus b, right? So if I wanted to find the area of the square, it would be a plus b squared. Does everybody agree with me? Okay. Now the four triangles, what's the formula for the area of a triangle? Do you guys remember that?
A equals 1/2 the base times the height.
Half the base times the height, yeah. So how many triangles are there? There's 4 times 1/2 the base times the height. Well, I can use A as the base and B as the height because it's a right triangle. So my legs are the base and the height. And then the small square is just going to be C squared. So everybody follow me so far? Okay. All right. So if I square A plus B squared, just like we did in our 5-a-days, it's not going to be A squared plus B squared, but it'll be A squared plus 2AB plus B squared. And 4 times 1/2 is 2, so 2AB plus C squared. Then if I subtract 2AB from both sides, I'm left with A squared plus B squared equals C squared. And so that's one of the proofs for the Pythagorean Theorem. Okay? Pythagorean triples. Pythagorean triple is 3 integers that satisfy the Pythagorean Theorem. 3 integers that satisfy A squared plus B squared equals C squared. So for instance, one of the most common ones is what, Zach? 3, 4, 5. That, now you guys know what Zach's been talking about all the time when he says, oh, that's a 3, 4, 5. Okay, because if you do 3 squared plus 4 squared, it is going to in fact equal 5 squared because you get 9 plus 16, that does equal 25. So one of the most common Pythagorean triples is going to be 3, 4, 5. But it's not the only one.
Isn't it like 13, 15, and 7?
We'll go over some other ones in a second. Okay, so we're going to find the hypotenuse of this triangle. So which one is going to be my C on this one?
X.
The X, because it's the hypotenuse. So that's the one that's by itself. So if I just say 24 is my A and 7 is my B, does it matter which one I say is A or B? No, the legs are interchangeable because you're adding them. It doesn't matter what order you add in. Addition is commutative, okay? All right, so 24 squared comes out to 576, and 7 squared is 49. So when I add those together, I get 625. So I know it's going to end in a 5, right? So you guys think it's 15 or 25?
25.
It's 25, yeah. So C equals 25. So now because C came out to an integer, I have another triple. 7, 24, 25. That's a new triple right there. So now we've got 2 so far. I'm going to have you guys figure this next one out on your own in your notes. Okay, so this one you're going to do x squared is equal to 9 squared plus 12 squared, which is 81 plus 144, which adds up to 225. And so hopefully you guys got x is equal to what? 15. Okay, so Zach, you did it a short way because you knew it was a 3, 4, 5 triangle, right?
Yeah.
So can you verbally explain how you did it to the class?
All the numbers have to add, like, if it's a 3, 4, 5, then a 3 has, it's 3 times 3, 4 times 3, then it's 5 times 3.
Okay, so what he noticed is that 9 is a multiple of 3 and 12 is a multiple of 4, right? So you divided everything by 3. So if you divide by 3 and divide by 3, that's how he got the 3 and the 4. So he knew x had to be 5 times 3, which is 15. Does that make sense? Okay, so that's kind of a shortcut way. When you know your triples, you can find the answers a lot faster. Okay, so now we get to have a word problem. All right, so a 6-foot board rests under a doorknob, and the base of the board is 5 feet away from the bottom of the door. Approximately how high above the ground is the doorknob? So first thing I'm going to do is draw myself a picture to go with this. So I've got my door here, and my doorknob, and I have a board that is 6 feet long, and it's 5 feet from the bottom of the door, and I want to know how high it is to the doorknob. So that's going to be my X. So this time, which one is my C? We assume that the door was straight up and down. Which would be my C? I heard somebody say 6, right? Okay, so x squared plus 5 squared is going to equal 6 squared. So you go ahead and square them out. So 5 squared is 25, 6 squared is 36. And then if you subtract 25 from both sides, you get that x squared is 11. And so x would just equal the square root of 11, which is approximately 3.32 feet. Now, do you guys think I just approximated the square root of 11 in my head?
No.
No. You guys finally get to use calculators in here. So yeah, you guys can use calculators to figure out your square roots. Okay, so for our next example, we're going to find the area of an isosceles triangle that has side lengths of 16 meters, 17 meters, and 17 meters. So again, since they didn't give me a picture, I'm going to draw myself a picture. And it's probably not to scale. It's definitely not to scale because the 16 is longer. Okay. So if I draw my isosceles triangle, when I draw the altitude, I cut the base in half, right? Yep. So each of these is 8. And in order to find the area, what piece of information am I missing? The altitude or the height. So I need to use the Pythagorean Theorem first so that I can figure out the height. So 8 squared plus the height squared is going to equal 17 squared. So we get 16, or not 16, 64. I'm not awake yet. And 17 squared is 289. So if we subtract 64 from both sides, I get that h squared is 225. And so the height is 15. So since my area is 1/2 base times height, the whole base was 16, right? So don't forget that. Don't take half of 8. And then the height was 15. So that would be 120 when you multiply it all out. Meters squared. And it doesn't matter what order you do it. You can multiply the 16 times 15 and then take half. Or you can take half of 16 and multiply that times 15. Just don't take half of both of them. Only take half of one of them. So I'm going to give you guys one to do in your notes after you're done writing that down. You're going to find the area of this triangle here. If it's hard to see, the sides are 50 feet and the bottom, the base is 28 feet. See if I can make it a little bit bigger. Okay, so yeah, when you set up your triangle, your right triangle, you cut the 28 in half and you get 14. And so h squared plus 14 squared equals 50 squared. You end up getting that the height is 48. So the area is going to be 1/2 the base times the height. And so it should have come out to 672 square feet. Any questions? All right. I didn't erase it. Oh. Okay. All right. So, yes, Pythagorean triples. So some really common ones are 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. And so what you'll sometimes see is that it'll actually be multiples of them. So another 3, 4, 5 triangle, if I multiply them all by 2, it would just be 6, 8, 10. So you'll see that one show up a lot. Or you can multiply it by 3, by 4, etc. So basically any multiple of 3, 4, and 5 will give you another Pythagorean triple. And again, you could double the 5, 12, 13, and you'd have 10, 24, 26. That'll show up in problems sometimes. If you double 8, 15, 17, you'd get 16, 30, 34, or the one we just did, 14, 48, and 50. So obviously, you can multiply them by 3, by 4, by 5, but generally speaking, what you're going to be seeing is multiples of like 2 and 3. So when you get an example, such as example 4 here, what you'll want to do is say, okay, is there a number that goes into both of those numbers? So what number goes into 45 and goes into 24? Can I think of a number that'll divide into 45 and 24? Obviously not 2. 3. They're both multiples of 3. So if I divide these both by 3, 24 divided by 3 is 8. 45 divided by 3 is 15. So now I've got 8 and 15. Which triple is that? It's up here, right? 8, 15, 17. So that means x has to be 3 times 17, or 51. So it makes it quicker, and so you don't actually even need a calculator to figure out Pythagorean theorem when you have large numbers. Because if it's one of the triples, it'll go really fast, okay? So here's a super easy one for you guys. Okay, so Zach already gave it away that it's a 3, 4, 5, right? Yeah, so what's x going to equal? Anybody besides Zach? 50, yeah. Because they're both divisible by 10, and so x would have to be 50. And that's it for today.